We eat cooked food every day. It feels normal. It feels like something we've always done. But we haven't. There was a time, a very long time, when our ancestors ate everything raw. They didn't have fire, they didn't know how to cook. So what changed? Why did we start cooking our food? And what did that change do to us? It did a lot. It changed our bodies, it changed our brains. It changed how we live together. It pretty much made us who we are today. Imagine our very early ancestors. Think way back. Think of them as more ape like, but walking upright. They lived in forests and savannas. Their diet was simple. They ate what they could find. That meant fruits, leaves, roots, tubers. And if they were lucky or smart or strong enough, they might get some raw meat. Maybe they scavenged from a predator's kill. Maybe they hunted small animals. But whatever they ate was raw. No heat, no preparation beyond maybe tearing it apart. This raw diet had some big problems. First, it was hard to eat. Raw plants are tough. They have strong cell walls that are hard to break down. Raw meat, too, is chewy and dense. Our ancestors would have spent a huge part of their day just chewing. And even with all that chewing, they wouldn't get much energy from their food. Their bodies had to work very hard to digest it. A lot of the nutrients would just pass right through them. Think about it. Eating a raw potato gives you almost nothing. It's mostly starch locked up in tough cells. Same with many other raw plants. Even raw meat, while providing protein, is harder for our guts to process efficiently than cooked meats. So, these early humans needed to eat a lot all the time just to get enough energy to survive. Their guts were big, very big, because they needed a large digestive system to handle all that raw, hard to digest food. They also faced constant threats from parasites and diseases that live in raw food, especially raw meat. It was a tough life, powered by a low octane diet. Then fire came into the picture. No one really knows exactly how we first got fire. Maybe lightning struck a tree. Maybe a volcano erupted. Maybe a grass fire started naturally. Our ancestors probably feared it at first. It was hot, it burned, it destroyed. But then, curiosity must have taken over. Maybe a piece of fruit fell into a fire, or a chunk of meat, and someone, maybe accidentally, tasted it. That moment changed everything. The first cooked food must have been a revelation. Imagine biting into something that was previously tough and bland, but now it's soft, warm, and smells good. Tastes different. It tastes better. This wasn't just about making food taste good, though that was a bonus. The heat did amazing things to the food itself. When you cook food, you do a lot of helpful things to it. For plants, heat breaks down those tough cell walls. It makes the starches more accessible. Think of boiling a potato. It goes from hard and indigestible to soft and floury. Your body can now get at all those carbohydrates. For meat, heat denatures the proteins. It unravels them. This makes the meat much easier to chew and much easier for our digestive enzymes to break down. The connective tissues soften, raw meat is stringy, cooked meat falls apart. So, the first big win of cooking was digestibility. Cooked food is just easier to digest. Our bodies didn't have to work as hard. They didn't need to spend as much energy on digestion. This meant more energy was available for other things, and this leads to the next huge benefit: energy gain. From the same amount of food, cooked food gives us a lot more usable calories and nutrients. If you eat a pound of raw meat versus a pound of cooked meat, you get significantly more energy from the cooked version. The same goes for plants. This was a massive energy boost for our ancestors. A game changer. And there was another critical benefit: safety. Cooking kills. It kills bacteria, it kills parasites. Eating raw meat, especially scavenged meat, was a dangerous business. It could make you very sick or even kill you. Cooking made meat much safer to eat. It also made some plants safe that were previously toxic. Some plants contain natural toxins that heat can break down. This expanded the available food sources significantly. Our ancestors weren't just eating better, they were eating safer. This new, energy-rich, safer diet had profound effects on our bodies over many generations. One of the most obvious changes was to our teeth and jaws. If food is easier to chew, you don't need such big, strong jaws. You don't need such massive teeth. Over time, our ancestors' jaws started to shrink. Their teeth became smaller. The powerful chewing muscles that animals need to process raw food started to reduce in size and strength. This freed up space in the skull, and that space became very important. Along with smaller jaws, our gut size also changed. If your food is pre-digested by cooking, your body doesn't need to maintain such a huge, energy-hungry digestive system. Think of a cow or a gorilla. They have enormous guts to process vast amounts of raw plant matter. Our ancestors eating raw had bigger guts than we do, but with cooking, their guts began to shrink. And less energy was needed to fuel and maintain this big digestive system. This freed up even more energy. Now, this is where it gets really exciting. What did our bodies do with all this extra energy? And what did they do with the extra space in the skull from smaller jaws? They used it for our brains. Our brains are incredibly energy-hungry organs. They demand a huge amount of calories even when we're just sitting around. For our ape-like ancestors, maintaining a large gut for raw food digestion and a large brain was a kind of metabolic trade-off. You couldn't really have both because there simply wasn't enough energy. But with cooking, that problem went away. More calories from less food and less energy needed for digestion. This energy surplus became available for brain growth. This is a leading idea called the expensive tissue hypothesis. It suggests that the energy saved from having a smaller gut and eating more digestible, energy-dense cooked food fueled the rapid expansion of our ancestors' brains. And when you look at the fossil record, the timing lines up beautifully. The big jump in brain size in our lineage seems to happen right around the time we think our ancestors gained control of fire and started cooking. So, cooking didn't just make us smarter, it allowed us to become smarter. It gave our brains the fuel they needed to grow and develop. And a bigger, more complex brain meant more complex thinking, better problem solving, and eventually things like language and art. But the impact of cooking wasn't just on our physical bodies and brains. It also had a massive effect on our social and behavioral lives. Cooking is a slow process. You need to gather fuel, you need to gather ingredients, you need to manage the fire, and it's often something done in groups. Think about humans gathering around a campfire. This is where stories are told, this is where plans are made, this is where bonds are formed. Social bonding became much stronger. Sharing cooked food around a fire created a central hub for the community. It encouraged cooperation. Some people might go out and hunt or gather, others might stay back and prepare the food. This division of labor made the group more efficient. It fostered a sense of community and mutual reliance. The act of giving and receiving food is powerful. It builds trust, it strengthens relationships. Cooking also changed how our ancestors spent their time. Before cooking, they spent a huge amount of time foraging and chewing. With cooked food, they needed less time to eat and less time to gather the same amount of calories. This freed up precious time that could be used for other things, making more complex tools, teaching the young, developing language, resting, thinking. This extra leisure time, if we can call it that, was crucial for cultural and intellectual development. And it might have even played a role in the development of pair bonding and family structures. Imagine a male hunter bringing back cooked meat to a female and her offspring. This provided a stable, high-quality food source for the family unit. The female didn't have to spend as much time foraging for herself and the children, which would have been very difficult with young, dependent babies. This consistent food provision could have helped establish more stable, long-term pair bonds between males and females. This, in turn, could have improved the survival chances of offspring, leading to more successful reproduction and the spread of these new behaviors. The act of sitting around a fire, preparing and eating food together, created a perfect environment for the development of language. There was a need to communicate, to coordinate, to share information. As brains grew, so did the capacity for complex communication. It's easy to imagine early language developing around the warmth and light of a fire, sharing a meal. And, of course, the increased cognitive development was key. Cooking itself requires planning. You need to anticipate needs. You need to remember where to find certain foods. You need to understand how to manage fire. These are all complex cognitive tasks that would have further stimulated brain development. Cooking is an early form of technology, and like all technology, it pushed us to think differently, to innovate. So, when exactly did this all happen? Pinpointing the exact start of cooking is hard. Fire leaves traces like charcoal and ash, but knowing if that fire was used for cooking and not just warmth or protection is tricky. And cooked food doesn't leave clear fossil evidence, but by looking at archaeological findings like hearths and charred animal bones, and combining that with biological evidence changes in our ancestors' bodies, scientists have put together a timeline. The control of fire, not necessarily for cooking at first, might go back as far as 1.8 million years ago with Homo erectus. There's some disputed evidence for very early fire use, but more solid and widespread evidence for controlled fire use, including for cooking, appears around 400,000 to 300,000 years ago, perhaps with Homo heidelbergensis, and definitely by the time of Neanderthals and early modern humans. The physical changes in our ancestors, the shrinking jaws and teeth, the changes in gut size, and especially the significant increase in brain size seem to align with these dates. For example, Homo erectus showed some reduction in jaw size compared to earlier hominins and had a larger brain. This suggests that some form of food processing, perhaps pounding or rudimentary cooking, was already happening. The most dramatic brain growth, however, seems to coincide with the more widespread and consistent control of fire and cooking. So, the why of cooking is not just about convenience or taste. It was a matter of survival and ultimately a powerful engine of evolution. It was a major step that allowed our ancestors to extract more energy from their environment. This energy allowed their brains to grow, it allowed their bodies to change. It allowed them to form more complex societies. It fundamentally reshaped our species. Cooking gave us an unprecedented energy advantage. It literally fueled our evolution. Without it, we might still be ape-like creatures, spending our days chewing tough raw food with much smaller brains and simpler lives. Cooking made us human. It allowed for the development of our intelligence, our culture, our language, and our complex social structures. Think about that the next time you eat a meal. Every bite of cooked food connects us to this incredible evolutionary journey. It's not just a meal, it's a testament to one of the most profound technological and biological shifts in our history. It's what allowed us to become us.